Hi students, welcome to Preliminary Chemistry and the Energy video series. This is video number 4 on carbon and its allotropes. We're going to focus just a little bit on some of the background for carbon because in this topic of energy, carbon is very important. It's the base for some significant compounds that are energy generators, and also it has some very unique properties that make it well worth studying. To cover the first couple of things, carbon is element number 6 in the periodic table. It's in the second period in group 4. It has an electron configuration of 2,4, so that's 2 around its nucleus, 2 electrons in the first shell, and then 4 in the second. It is tetravalent, and that means that each carbon atom can share an electron pair with 4 other atoms. It forms a tetrahedron kind of a shape, and this is where the 8 electrons or 4 pairs of electrons are equally distributed around the central carbon atom. This means it bonds readily not just to other carbon atoms but also to a range of other types of atoms. The carbon atoms themselves are relatively small. They have an atomic mass of 12 for certainly the most common isotope. And carbon atoms can form stable chains or networks or rings by means of these carbon-carbon bonds. And this has allowed carbon to exist in several different forms, and to describe those different forms we use the term allotrope, and I'll talk about that in a moment. But these 3 different forms, diamond, graphite, and also a few other variations of carbon, one of which is known as Bucky balls or Buckminster fullerene, just examples of different types of carbon allotropes. So let's look at these in a little bit more detail. So what you can see over here is diamond, which is one allotrope of carbon, and graphite, which is a second allotrope of carbon. You can already notice straight away that their appearance is very different, and so are many of their physical properties. We know, for example, that diamond is the hardest substance on Earth. Graphite certainly nowhere near as hard as diamond. And if we want to look at why these properties and what we can use each of these for, then we need to look in a little bit more detail at their structure. And it's when we look at their structure that we start to understand that carbon can exist in 2 very different forms. Now, if we have 2 substances with the same chemical formula but 2 or more distinctly different forms, then we have what are called allotropes. And allotropes are just things like diamond and graphite. Diamond and graphite are 2 allotropes of carbon. They consist of only carbon atoms, but the ways in which the carbon atoms are bonded to one another is quite different for diamond and also for graphite. And it's this difference in bonding arrangement that actually gives each of these 2 their slightly different properties. There is a third allotrope of carbon, often referred to as Bucky balls, which I mentioned before. We'll look at these in class, but we won't have a look at them too much detail on this particular video. All I want to do at the moment is just begin the process of comparing the different allotropes, and I'll develop these a little bit more in the next video. For the moment, be aware of the fact that because we know that probably the thing we know most about diamond, apart from the fact that it's very sparkly, a very valuable jewel, is also that it's extremely hard, the hardest substance that we know. And it is network covalent bonding that is responsible for this. There's no weaknesses within the bonding arrangement of carbon atoms in diamond. And this makes it an excellent substance for cutting other gems. So it's often used in diamond drills because it pretty much will cut anything. And as a consequence of that, that makes it a great substance as a cutting substance. Graphite, on the other hand, has strong networks within layers. So within a certain layer, the carbon atoms are very strongly bonded to each other. But between the layers, it's weaker. So there are weaknesses between the layers in graphite, and this makes it softer. It makes it suitable as a lubricant. It's often used for that purpose. And the fact that it is in layers also means that there's some ability for electrons to move between the layers, and this gives graphite a quite unusual property for a non-metal, and that is that it's a quite good conductor of electricity. And we've used this principle to help set up some of our galvanic cells or electrolytic cells, where we use carbon in the form of graphite as an electrode to allow it to conduct electricity through the solutions. So it's the layered arrangement that we see in graphite that makes it softer than diamond, allows it to conduct electricity, and also makes it suitable as a lubricant. But that very strong network bonding with no weaknesses in the diamond is what makes it such a hard substance. And we'll look at the link between these in a little bit more detail, as well as some other implications of these allotropes in the next video. Thanks for watching.